Hello the internet and welcome back to my channel. Some time ago I fixed the sound interface on this channel, a Focusrite 2i2, and I've been using it for some work, and today I've decided to upgrade to a bigger model. It's a Focusrite AT920 Generation 1. This came second-hand and it features 8 analog inputs and 8 analog outputs. To be fair, I started this video as a second channel video. I thought it would be uneventful. Take a look at the interface, maybe take a look inside, make sure everything works. Well, the last part, making sure everything works, well, that didn't work very well. The interface ended up being faulty, but not just one fault. 3 different faults, including a weird manufacturing fault, which apparently belongs to a whole batch, so keep watching if you have an AT920 Generation 1. So I decided to promote the video to the main channel, but now I'm making a voiceover as videos on the second channels tend to be on the long side. So let me thank today's sponsor, PCBWay, and now let's start taking a look at this new interface. To test the AT920, I'm going to use a real-time analyzer software called smaart. This is analyzing the sound from the interface, displaying a graph which represents the sound being read from the inputs. The amplitude or volume is on the vertical axis, the frequencies from 20 Hz on the left to 20 kHz on the right are on the horizontal axis. I want to make sure that all the inputs and outputs are working and are able to record and reproduce all the frequencies in a linear fashion, so I'm going to use some pink noise, which sounds like this. Pink noise will read as a flat line on a spectrum analyzer like this. When I started testing the inputs, I noticed something weird. The green line you see on screen is pink noise I'm feeding into input channel 1. It looks flat as expected, but the signal seems to be leaking onto channel 2 in blue here. This is technically called crosstalk, when one channel affects the adjacent one. It turns out that all channel pairs are affected. Channel 1 affects channel 2 and vice versa, channel 3 affects channel 4 and so on. I was puzzled as other interfaces do not show this, so I started looking online and I found one mention of this issue on the Gearspace forum. One user there suggested it was a known manufacturing issue and that Focusrite was aware and fixing it for free. That's a classic of second-hand things I buy, I guess. While I was testing the interface, I also noticed a 50 Hz spike on all channels. Not very loud, it peaks at around minus 120 dB, which is very low, but annoying for me as I'm using the AT920 to test other devices, so quiet inputs are important to me. So I contacted Focusrite to see if, after all these years, they were still happy to help me with this crosstalk issue. In the meantime, I opened the interface to take a look inside and maybe see if I could identify the cause of that 50 Hz issue. However, once the interface was opened, and without touching it, the interface was dead. When I flipped the power button, I could hear a click, but the power LED was not on and the whole digital section seemed dead. My laptop did not detect the interface anymore. I promise you, I didn't touch it. So, let's take a look at the PCB and see what's going on. The power supply here says 5 volts, ground, 15 volts, ground, minus 15 volts, ground, 51 volts, which is for the microphones. Now, first thing first, let's measure some voltages here, and I'm measuring here on the main PCB, and we got the 49. It says 51, but again, if 49 volts, and it was minus 15 maybe, yeah, which is minus 13.7. Again, it doesn't have to be accurate. Then I think it's the plus 15, which is 13.67. And then we have the 5 volts somewhere here, which is 5 volts exactly. Perfect. We also have a test point for 3.3, and we do have 3.3. Perfect. Alright, I found there's actually a test point for the 1 volt, which is here. So I think this is the 1 volt generation. Obviously, it's close to the main processors. So let's check here. Oh, we haven't got 1 volt. Oh, you can't see that. We've lost we lost the 1 volt. How is that even possible? Look at that. There's nothing on 1 volt. I didn't do anything and now we haven't got 1 volt. Okay, fair enough. Alright, plot twist. I promise you I haven't done anything. It says 1 volt and the front panel is now on. I don't know what's going on. I turn it off and on with the probe in place. because I thought maybe we have some voltage and it goes away straight away. This is cool. Let me try this again. 3, 2, 1, go. Now it's working. Now it's working. I don't like when things fixes by themselves. Well, there's nothing to fix now, and I guess I'll wait until it happens again, if it happens again. Right, I've done a little poking around and it died again on me, so it was again not working as before. This is the IC which is looking after the generation of the 1 volt for the CPU. And I looked at the datasheet, and the pin here on the right, the pin on the top right, is the voltage in. So I can see that this voltage in is going on the side of this stack capacitor, yes, and which is then connected to the test point / via. But what I've discovered is that now it's switched off. If I turn it on now, it's actually working now. The 1 volt is generated from the 3.3 volts. We know that the 3.3 volts was working before when the interface was dead. Well, with the digital section completely dead, the 3.3 volts was there. I don't know whether it was reaching there, but either it doesn't reach the regulator, or there's a mechanical problem like a bad joint, solder joint, or that kind of stuff, or there's an issue with the regulator. But at least we know that the 1 volt is generated from the 3.3 volts, not from the 5 volts. Right, I was doing something else and I switched on the Scarlett and it's in that dead state, so the digital section is not working. Let's see whether we have the 3.3 volts going into the regulator here. We do. So we do have the 3.3 volts, but we don't have the 1 volts out. I had a look under the microscope. I can't really see anything there. So I'm wondering whether it's an intermittent problem with the regulator itself, so might need to be replaced, or it's just a bad contact somewhere. It doesn't seem so. Now the regulator is also getting an enable pin. You can try and take a look at that, even though things are getting a bit smaller there. Right, I think this is the enable pin. It says 1.3 volts. So the enable pin is 1.3 volts, and I'm wondering whether that's enough to turn on the 1 volt. So let's turn it off and on again, see if I can put it in a way that it works and we can check whether we have the same voltages. Okay, it's working now, and I still have 1.3 as enable pin. So it's not an enable pin problem, it's not a source problem, so it's either a mechanical problem or the regulator is faulty, because that regulator has everything inside. It's a switching, I think it's a buck converter, it's got everything inside. So if that's not outputting voltage, the problem is there. I don't think there is anything else that could cause the problem. So I would say the next step would be to reflow the area and see if it happens again. If it does happen, I'll get another regulator. Okay, a few days have passed and Focusrite are now hinting to the possibility to have a free of charge repair of this board if it belongs to a known faulty manufacturing batch, which is great. That being said, there are 2 issues I would like to tackle before I even think of sending this to Focusrite. One is the missing 1 volt that goes to the CPU. That happens every now and then. I've been using this interface a little bit and it happens totally randomly, and I need to find a way to reproduce it, but we'll take a look at that in a minute. The other thing is the 50 Hz noise that is present on all the inputs, and I'm assuming all the outputs. I haven't checked that, but it happens even with nothing connected to the interface. Right now on my spectrum analyzer, I monitor channel 1. There's nothing connected to channel 1, and you can see there is a spike of 50 Hz, which is not too high actually, and I think I understand why. Because the board, the interface is cold. I've just turned it on, and it looks like that with time, over time, when it heats up, that 50 Hz becomes a bit more severe, which is probably not a problem if you're actually using this to play sound in a room. But for me, I'm testing equipment. I need to have the noise floor of the interface as low as possible. Let me keep this on for a little while and let's see what happens to that 50 Hz spike. And I've used my hotter station to warm up a specific area of the board, and look at that. You have in red is when the interface was cold a moment ago, and in green is real time, the massive 50 Hz spike out of the interface, actually out. This is what is being read of channel 1. There's nothing plugged in, there's nothing plugged out, it's only USB and power. Now, I am certain that this is not coming from the power supply on my laptop through USB, because I've also tested this without the power supply on batteries, and there's also nothing connected to the interface at the moment. So this can only come from one place, mains. I'm in the UK and mains voltage is running at 50 Hz, and unsurprisingly we get a 50 Hz spike coming through the interface somehow. Now, what I have warmed up to simulate, like use hours of use of a closed interface, is the power supply. And in particular, I think I spotted this very capacitor. It's a 470 microfarad 16 volts. I don't know whether it's on the 15 volts line or maybe the 5 volts. I guess we'll know in a minute. And I think I can show you what I mean. Let me warm it up a bit, and then we'll cool it down and we'll take a look at the real-time spectrum analyzer and see what happens. You can see how fast the 50 Hertz spike is going up in volume, basically in amplitude. Now let's cool this down and see what happens. And more or less the 50 Hz has gone down to what it was when I turned on the interface. I'm actually not entirely sure it's that capacitor or maybe the adjacent one, but to me that points to a power supply failure, which is pretty common. Now these capacitors throughout the whole board are pretty average quality or low quality if you want to call it, and most importantly they're rated 85 degrees Celsius. So what I'm going to do, I'm going to recap this whole power supply, and then we'll see whether the 50 Hz improves, stays the same, or whatever. But I have a good feeling that that's going to be our problem. The power supply is a very simple one. It's manufactured by Ferrix, and I think it's model FB07M063 revision 3. Again, it's 5 volts plus and minus 15 volts and plus 51 volts for the phantom power. It's a single layer power supply, so it should be fairly easy to replace those few capacitors. Alright, I've got a 75 ohm load on the 5 volts line, and that should give a 333 milliwatts load. I have a feeling the 5 volts is the main line that needs to have a load for the whole power supply to stabilize. So let's give it a go now. I'm monitoring the minus 15 line, and yes, it's got stable at minus 15.8, 51 volts. It's 55 as it was before, and the 15 volts line is at 15.46. That's great. Let's double check the 5 volts is still okay, and it's still totally fine. So yeah, the power supply is very simple. It just needs a little load. So we are ready to reinstall this into the Focusrite. Right, the power supply is back. I made a little mistake. I have a bad feeling about it. I didn't think too much about discharging the outputs. The main capacitor here, yes, but not the outputs. I forgot there is a 50 volts output. And when I went to plug the connector here to the motherboard, there was a spark somewhere. At least I think there was a spark. And there were still 30 volts on that line. So hopefully I just shorted that line to ground. I made this mistake already on this channel when I was fixing some amplifiers. I'll put the link in here and down below in the description. So hopefully nothing happens. I have a bad feeling about it. I would hate to lose this interface, but we'll see what happens. I'm monitoring 5 volts in 3, 2, 1, go. Got 5 volts. The interface is kind of coming back to life. Now, on this occasion, I don't have 1 volt. Is it because I fried the interface or because it's just in one of those moments and it doesn't like it? But let's check the 15 volts. We got 15 more or less. And let's check minus 15, which is a bit on the low side. And the 50 volts is at 49. Everything is a bit on the low side, but I do see no activity here on the 1 volt. And I'm guess that if I'm checking the 1 volt pin, test pin here, and I turn on, Yeah, there's no 1 volt. So hopefully it's the usual thing. And hopefully I'll know how to fix it, at least temporarily. Looks like the one I'm cooling down that thing, it comes back to life. Let's see. It's actually a good opportunity to test this little theory. Turn this on again. Yes, we got 1 volt, so that theory works and the interface seems to be working. Let's plug this into a computer and see whether that actually sorted the 50 Hz problem. When it comes to audio project, PCBWay has a whole audio section on their shared project webpage where you can browse and order PCBs directly. If you find something online that you like, well, all you need is the Gerber file, upload it on PCBWay.com, the process is automatic and PCBWay will deliver the PCBs at your place. If you follow my channel, you know that I've been using PCBWay for quite some time. I cannot complain about the quality of the PCBs, and the customer service, honestly, is top-notch. The 7th project design contest is on. Take a look on PCBWay.com whether you wish to participate or whether you would like to browse through all the submissions. It's an amazing contest, and this year there's a new category, STM32. If you're thinking of designing something which is using an STM32, well, there's a dedicated category for you. Take a look at PCBWay.com, the link is also down below in the description. Let me thank PCBWay for sponsoring my videos, my channels. Their help makes these videos possible. Now let's continue with this Focusrite. And no, the 50 Hz is still there. I'm so surprised because we could trigger it higher or lower with temperature, and I'm surprised that it's still there. So I don't know, I'm wondering whether this is kind of I don't want to call it design flow, but maybe that's it. That's what the interface can do. After all, it's very low in level. Let's see whether temperature is still affecting it or not. Right, temperature is still affecting it, but it's not a capacitor. At least I doubt that, one of these brand new high quality capacitors can have that effect. So I can't think of anything else. I'm definitely only warming up that section. I'll have to think about it. Right, let's move to the 1 volt problem not coming up every now and then. Now, I've been using this interface a little bit and it mostly works, and sometimes it just refuses to power up. So what I like to find today is whether I can replicate that behavior with hot air and cold spray. And then I think I want to reflow everything around it, because from what we inspected last time when it was happening live on camera, there's nothing wrong with it. We have 3.3 volts coming in, we got the enable pin, which is enabled, and the remaining would be the feedback pin. I'm not sure whether that, if it's not there, it might be causing some issues, but that's just a couple of resistors. And because sometimes it works, it means the resistors are working. I'm really thinking of a bad joint, even though it might not be visible, there might be like a micro crack somewhere. So first thing first, the interface is off now. And that's my 1 volt test point. I'm going to warm up that area and see if by any chance it stops working. And then if it does, I'll cool it down and see if by any chance it starts working again. So at least if I reflow everything, I have a way to test it. Because right now it's very, very random. Let's turn on now. Nope, it's still working. Let's turn on again now. And it's still working. Okay, so no, that method doesn't work, unfortunately, and that kind of removes the certainty that whatever I'm going to do is going to work, because I can replace whatever I want, but I've been using this for a couple of weeks and it mostly works. But right now, before replacing anything, I just would like to retouch those soldering joint, have a look under the microscope, maybe we can see something under the microscope, and then I'll test it again, and if it happens again, then I'll replace the regulator. Alright, this is the section looking the 1 volt generation, and it is very simple. This is the main regulator and it's working with 3.3 volts as we noticed. Now the 3.3 volts regulator has got 3.3 volts coming in from the top right pin, so 3.3 volts comes here, we have a capacitor, and then 3.3 volts comes into the regulator. The enable pin is the 3.3 volts itself, it's just dialed down to 1.3 volts, and that's totally fine. It's going through a transistor, some other component, but basically whenever 3.3 volts is up and running, it gets into the regulator to say, I'm up and running, you can go ahead and use 3.3 to generate 1 volt. So the enable pin is this bottom left here. The bottom right is the output of the regulator. It's outputting 1 volt, but this is a buck converter, so it's a switched output. So we have an L1, an inductor here, and then we have a capacitor in parallel with ground and another capacitor, an electrolytic, in parallel with ground. So that here at this pad here, we have our 1 volt test pad, and this is where the 1 volt is finalized. Now the IC receives feedback, and it's this line here, which is coming from basically the 1 volt, the finalized 1 volt, and it's going through a voltage divider with an extra capacitor for whatever reason. We got these 220K resistor and this 150K resistor. I know it says 18, but online calculator says this is an 150K, and it goes into the top left pin, which is the feedback. And the idea is there's a formula on the data sheet that basically you use to calculate what kind of resistors you need to have the amount of voltage that you're looking at the output. And based on the voltage that comes back, the regulator knows exactly what to do. Before I go ahead and replace this, I'd like to reflow those joints, and then I'll test it again. If it happens again, then I'll replace the regulator. I can't think of anything else. It's a very simple thing. Let's reflow everything here, and then again I'll test it over. I guess it will take some time before I can say, yes, this is working, or no, it's not. Alright, all done, time to test. Let's see if it works, and if it does, it will take a little while to find out whether it's a permanent solution or not. 3, 2, 1, go. Yes, it works. Perfect, so I will test, and fingers crossed, that's all it needed. A couple of days have passed, and the Focusrite has refused to power up a couple of times. Only a couple of times, but clearly we still have a problem with that 1 volt line. Now it's a simple circuit, so I'm going ahead and replace the regulator. Now I got a bit paranoid because I purchased those regulators from AliExpress, and there's a good reason for that. It's completely discontinued and it's not available from Mouser or DigiKey. To be honest, AliExpress is the only source available. And I thought, what if this regulator is fake? What if I fit it into my very nice Focusrite 18920 and suddenly sends 3.3 volts to the CPU? Will the CPU like it? Unlikely. So what I'm doing with this breadboard, I'm testing the regulator. I've installed the regulator on this little PCB, which is used by my programmer. It's not exactly the right type to solder it, but it should work. And what I'm going to do, I'm going to feed 3.3 volts on this line here through one of my bench power supplies, and I'm going to feed 1.33 volts on this other line through my other power supply as the enable pin, exactly as on the Focusrite. Now I got the circuit from the data sheet of the regulator, but also from the schematics available for the 2i4, which is more or less the same thing. It's a similar regulator. So it is very simple. The 3.3 volts goes straight to the regulator, and the enable pin also goes straight to the regulator, but I've added a 10K resistor to pull it to ground when the power supply is switched off, because I don't think it will like for the enable pin to be floating. On the output, I have an inductor. It's a random inductor. I think it's the only one I have in my component tray. It might be a bit too big, but hopefully for a test it's going to be fine. I have a 10 microfarad capacitor. Again, I think it's from the data sheet. And I've added a 33 ohm load just to give a little bit of load in case it doesn't like running without a load. The output is going back to the feedback pin through a voltage divider, and these two resistors, one is 220k, the other one is 150k, exactly as I found on the Focusrite. And actually, if I check these values with the formula which is given on the datasheet of the regulator, I actually find that that's supposed to work and produce 1.0 volts at the output. And finally, I'm probing the voltage at the load using my multimeter, so you're gonna see the voltage output here on my meter. So let's check whether this works. This power supply is the 3.3 volts, and this is my enable pin at 1.33 volts. So let's enable 3.3 volts. Perfect, and we have no output. And let's enable the enable pin, 3, 2, 1, go. Amazing, we got 1 volt exactly output, 1.028, which is totally fine, is exactly what I am expecting. So hopefully this is telling me that the regulators are actually regulators. Hopefully they're not fake. Hopefully they will last for a long time and they will never destroy my interface. Now, let's very carefully remove that regulator from the motherboard and let's replace it with that one. Alright, it's time to check the Focusrite, make sure that the 1 volt is working fine, and obviously I will need to replace those resistors at some point, but because I chipped them last time, I reflowed everything, I'm assuming that everything is still working fine, finger crossed. Multimeter is directly connected to the 3.3 line, and I'm ready to power up. In 3, 2, 1, go. Yes, we got 1 volt, and the board has initialized, so happy days, it's still working. All good, and I can breathe now. And Focusrite has come back to me with great news. They have surprisingly acknowledged that this interface actually belongs to that defective batch from manufacturing, which causes the excessive crosstalk across channels. And even more surprisingly, because this interface is 10 years old and I'm not the first owner and they are aware of that, they have offered to fix it for me free of charge. So massive kudos to Focusrite for taking full responsibility for this issue because it's coming from manufacturing. So the next step is going to be me sending this to Focusrite. I'm told by Focusrite it's a relatively simple fix, so hopefully when it's coming back, we are taking a look, I will be able to document it just in case someone needs this information, because this information is nowhere near on the internet. Now, I have also asked Focusrite about a very, very mild 50 Hz noise I have on the inputs. So what I have agreed with them is that they take a look at that. And if they tell me that this is within specifications and that's expected, or maybe it only happens here, it doesn't happen at the labs or something like that, well, then either I'll live with that or maybe I'll find another interface. If not, hopefully they can fix it for me and maybe I'll have to pay for that, that's totally fine. And I will try to document what they've done to fix that 50 Hz as well. So I would say, let me take lots of pictures of this board, and the next step is going to be to send it back to Focusrite and we'll see what happens when it's back. The 18920 is back from Focusrite. I haven't opened the box, so let's do this together and let's test it. Okay, I've got the Focusrite turned on and connected to my laptop. I've got Smaart running and the input gains are more or less set to 50%. Now, Focusrite looked into that 50 Hz noise that I reported and they claimed they fixed it by replacing the power supply, apparently, which is quite unexpected because I replaced all those capacitors. It's also a bit disappointing as that power supply had brand new capacitors on it, and especially the big bulk one was kind of expensive, so it's kind of a shame that it went into a bin at Focusrite somewhere, but it's great that apparently this has been resolved. So first thing first, let's just check all the inputs. I've got nothing connected to it, so we are going to check the noise floor. And I'm turning on the inputs now. And yes, everything looks very clean. These are all the 8 inputs at the same time, and there's basically nothing there. Just a little bit of small spikes, but nothing obviously to be worried about. The 50 Hz is definitely gone. You can see here on the analyzer, there is a very, very minor 50 Hz spike, which I guess, you got 50 Hz coming in. It's kind of, we're talking minus 152 dB, but previously it was so much higher. Here I'm overlaying 2 traces I saved before sending the Focusrite to Focusrite, and the purple one was with the cold interface, and the blue one was with the warm interface. So we're talking about 15-20 dBs lower than it is right now. So I guess this is a massive improvement. Now let's check the crosstalk issue, which is the main reason why this interface went back to the manufacturer. So I've got pink noise coming out of output 1, and I'm gonna plug it back into the interface on input 1. So let's see what happens now. 3, 2, 1, go. All right. Well, that's not what I was expecting. So channel 1 is green, and channel 2, which is the one which was affected before by the crosstalk, is blue. I mean, it's definitely lower than before, because I think before it was like, I went back to like minus 60. It was only 30 dBs at very low frequencies. So it looks like we got an extra 30 dBs of separation, but this doesn't look like a fix. It looks like a mitigation in my mind, because channel 2 is still affected, and you have quite a lot of, I would say, distortion or spikes anyways, coming out from the other channels. Let's try, if I plug channel 2, I guess it's going to be the other way around. Yeah, it's less affected, surprisingly. So I got some pink noise in channel 2, which is blue, and channel 1 is affected, but a bit less than if I'm doing the other way around. Let's try channel 3. And channel 3 is red, and I definitely have something coming out of channel 4, plus all those spikes on all the other channels. Let's try channel 5. And once again, we have channel 5, which is slightly affecting channel 6, and channel 7, which is slightly affecting channel 8 plus all those spikes. Now, this is definitely better than it was before, but I wasn't expecting a mitigation, I was expecting a fix. I don't think I'm going to complain about that. It's just I'd like to understand, the purpose of all of this is like, are all the Scarlett AT920 Gen 1 like this? So, because I'm not entirely sure whether this is kind of expected from a multi-input interface or not, well, I went back to my Moto 4 Pre interface. This is something I purchased many years ago, and it should be more or less from the same time period of the AT920. So I set up exactly the same thing. I've got the spectrum analyzer running with the same vertical scale, so that we can compare things, and I've cycled through the 4 inputs with pink noise coming from the interface itself, and I can see that when I'm using one input, all the other inputs are 100% unaffected. There's nothing on the other inputs. No pink noise, no crosstalk, no spikes, no nothing. Now, Moto interfaces are very expensive, so you might say, hey Tony, this comparison is unfair, the Moto is so much better, it used to be so much more expensive, which I can't remember to be honest. But, I also happen to have a 2i2 Gen 1, so this is exactly the same generation of these AT920, it's just a smaller model. The AT920 used to be like the high end of the whole Scarlett family back in whenever these were available. So I tested the 2i2 exactly in the same way, and no, the channels are completely independent. When I'm feeding pink noise on one channel, there's absolutely nothing on the other channel. And this is, again, it's the same family of the AT920 I have here on the desk. So at this point, I'm a bit puzzled. I'm not complaining too much about that. That's totally fine for my needs. And most importantly, the 50 Hz nastiness has gone away. So thank you very much, Focusrite, for taking care of that for me. But now I'm wondering what's going on with the AT920 Gen 1. Are all like that? Or is it just a specific batch which had an issue from manufacturing which Focusrite could mitigate but not resolve 100%? Maybe they're all like that. And this happens because the interface has many inputs and it's impossible to make that completely separate at that price point. I really don't know. What I know is that my 2 interfaces here, they don't have this problem at all. Now, I cannot complain about Focusrite customer support. They helped me, and to be fair, they actually didn't ask me any money whatsoever, including the replacement power supply, which I was pretty happy to pay for. But they came back to me saying, don't worry, it's going to be a free of charge repair. So I can't complain. The customer service has been top notch, and I really praise Focusrite for standing behind the product and saying, no, we want to fix that because that's the manufacturing problem. But I would have expected them to tell me, look, we can only mitigate it, we can't fix it 100%. Do leave a message down below if you have experience with this, if you were able to test your interface, whether it's a Focusrite, a Motu, or something else with a spectrum analyzer. Do you see this same problem? Maybe with the 18820, have you got a Gen 2 or a Gen 3, and can you do the same comparison and see whether whether you have any crosstalk at all? I think you can find the spectrum analyzer online, but you can actually see the little crosstalk from the channel input. You can see I'm sending pink noise on channel 7, and channel 8 is mildly active, while all the other channels are completely more or less switched off. Anyways, I'm gonna send a message to Focusrite because I would like them to have an opportunity to, reply to my observations. So far, they didn't know that I was gonna make a video. They didn't know I was a YouTuber. So all they've done here, all the free of charge repair and the massively impressive customer service, were for the average customer. I never mentioned I was going to be making a video about this. But on this occasion, I think I will report them back my finding and say, look, I'm gonna make a video about this. Would you like to reply? Would you like to comment about this? So if Focusrite are able to send a reply, I will just add a segment right now. Well, what matters is that the crosstalk is massively reduced, the 50 Hz is gone, and the 1 volt to the CPU is working totally fine, so I can totally use this interface. Now, to finish off this video, let's take a look inside and see what Focusrite did to fix that crosstalk, or to mitigate that crosstalk problem, and we can take a look at the brand new power supply, I guess. Ooh. We got yellow capacitors. The replacement power supply is from the same manufacturer, but it's a different model. For whatever reason, it looks exactly the same. All the components are there in the same position. So I don't know why it comes with a different model. Must be a reason for that, but it looks exactly the same. There are very fancy yellow capacitors from the most unknown manufacturer I've ever heard in my life. Topascon, if I'm saying that right. I don't know where they find these capacitors, but I never heard of them. But they look very fancy yellow. They look nice. Now, when it comes to the crosstalk modification, I don't need to look around because Focusrite sent me the job sheet, and the job sheet detailed exactly what happened with that modification, which is adding these 4 electrolytic capacitors, 470 microfarad, 6.3 volts, piggybacked on these SMD components. These are ceramic SMD capacitors, and they just piggybacked these 4 capacitors on top. Now, I've seen this mod before, because when I was looking for information about these Focusrite, or even my 2i2 when I was repairing it, there's a very nice blog, it's called Kron's Cave, and the guy there did a teardown of an 18820 Gen 1, so that's where I got all the information about the voltages and everything, and he found these capacitors on his interface as well, and he thought it was someone's attempt to mod this interface. He said, I doubt this is factory, but no, this is factory. And this is definitely the crosstalk modification to mitigate, at this point, the crosstalk problem with these interfaces. So if you happen to have an 18820 Gen 1, you might want to make sure whether you have that crosstalk or not, and you might want to get in touch with Focusrite. I'm sure they will be able to help you, but if you really wanted to do this by yourself, and you take full responsibility, of course, I see only 4 capacitors, 470 microfarad, 6.3 volts, piggybacked on those SMD capacitors. Pay attention to the polarity, of course, of the electrolytic capacitors, and apparently that's all that was done on this interface. Now, I'm sorry for mentioning this Focusrite, but while I was inspecting the PCB, I found some, I think it's either a capacitor leg or a piece of solder wire on the PCB. It's just laying there. Thankfully, it didn't go anywhere during shipment, but this would go somewhere at some point, and it shouldn't really be there. I wasn't expecting to find it there. So that's a big red flag, unfortunately. Mistakes can happen. I'm not pointing the finger at anybody. It's just that's a pretty serious one. You know, that could destroy this interface or damage this interface if it travels somewhere. So yeah, unfortunately, that's what I found. Now let's try and take it off the board and see what it is. Yep. Now, before I end this video, just a quick thermal analysis of this interface. Now, I had a look with my thermal camera and I found these two big resistors which say hot on the PCB. They're actually running pretty hot, about 100 degrees, and this is with the lid removed. So obviously with the lid in place and the interface running for many hours, I guess they would probably go higher than that. The power supply is making quite some heat at the same time. I don't know, it kind of feels like a recipe for a disaster. Most of the capacitors around those resistors are only rated 85 degrees. The one here in the top right is actually 105. The interface is completely sealed. There's no ventilation slots or anything. There's no fan. And I do appreciate there's a good reason for that. Maybe it's a sound device. Anything can cause noise on the outputs. So I can appreciate this. This just doesn't feel the best choice, let's put it that way. I'm wondering whether an external power supply would have been a solution, that removing quite a lot of heat coming from the power supply itself, even though I appreciate the convenience of having mains going into the interface, so you don't have to worry about another brick that you have to install somewhere. But if this interface is being run like 24/7 in a professional environment, I can see things getting really toasty in this area here. Despite all, I am massively impressed by Focusrite customer service. There was no hesitation in helping me out, and I was actually surprised that they offered to fix this interface, including the power supply, completely free of charge. And as I said before, I didn't tell them that I was a YouTuber, I didn't tell them that I was going to make a video about it, and they knew that this interface was secondhand. So massive kudos to Focusrite for the brilliant customer service in 2024. These things don't happen very often, unfortunately. So if you own an 18920 Gen 1, double check the crosstalk problem on your board and get in touch with Focusrite if you feel that your interface needs the modification. I was actually a bit surprised not to find any information about this issue and this modification anywhere on the internet but one website. I will make sure that there is a link to this video, if they allow me to do that, on that forum, so other people maybe can find out about this potential issue on the 18920. And it's nice to, you know, be able to reveal this kind of problem on something which is not documented anywhere else on the internet, apparently. Thank you again, Focusrite, for your help with this interface, and I hope you all enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel if you like this kind of things. Don't forget, I'm also on Patreon. My Patreon names are scrolling at the side of the screen. Thank you very much to all my supporters. I wouldn't be able to do this without you. There is a free tier on Patreon, so no excuses, but if you don't want to join me on Patreon, which I completely understand, maybe you can buy me a coffee. The link is down below in the description. If you don't want to buy me a coffee, well, that's totally fine. You'll visit here, maybe a like, a comment, that would massively help, and I do appreciate your time here. I hope you enjoyed it. That's it for today. Thank you for watching, wishing you a great day, and hope to see you soon here again on my channels for my next videos. Thank you very much, and goodbye. Bye bye.